Hi, in this lecture you will learn how to use the collections in packages. As I said before in the collections lessons, collections are used best with the subprograms and packages. Especially with packages, you can easily send and get the collections from one to another. So this will make our code more powerful and more efficient. Because inside of the packages, you can have your own types without creating it in a database. You can have your own nested tables, associative arrays, v-arrays, records, etc. And you can share all these among the subprograms. Actually, you will see me so many times when using the collections inside of the packages in the next lectures. So I will show you how to use them with the associative arrays in this lecture for now. Because, as I said before, associative arrays are the most useful collection types only if you don't want to store that collection in a table. Since I will need to use collections within a package generally, I will mostly use this collection type in my lectures. So let's start making the examples without further ado. Before creating our example, I want you to inform you about something. Try to type just like I do, because this example may be a bit complicated for you now. And if you type a little different, it might be hard to correct it for you for now. So this example will have 4 new subprograms and some new values, types, records, etc. The main idea of that code will be increasing the salaries of the employees who has a lower salary than the company standard. We assume that our company has a standard above the minimum salary. For example, the salary of every employee will be over 5,000. And in this example, we will increase the low salaries based on our salary increase rate. The salary increase rate means increase all the salaries with this amount. You saw that in the previous lectures. Alright, this example is not for simply increasing all the employees. It will be a bit complicated because generally you will need to create some complicated logics in a real work. So in this example, the high salaries will not be increased, but the low ones will be increased for once. After that increase, if any of our employees still has the salary lower than our standard, it will be rounded to the minimum salary standard. So we will first increase the salaries and recheck if any of them are still below the minimum salary standard. If so, it will be rounded to the minimum salary standard. At the end, all the values will be updated in the employees copy table. So this will be a good, comprehensive, and a bit complex example. So watch carefully and try to write just like how I do. Alright, we start modifying our packages starting from the package specs, because we can compile the package specs without doing the changes on the body. But we cannot compile the body first because it will return an error if the structure of the subprograms does not match with the spec. Since we will add new subprograms to our package, we start with our spec. Great, now let's start with adding an associative array type into our package. We will use that associative array with the subprograms and send and get the variables created with that type. So let's start typing then. We write type emp table type is table of employees %row type and index by PLS integer. I said index by PLS integer because I want to keep the employee IDs as index. Since employee ID is a number type column and all the values are whole numbers, I used PLS integer because it's faster than the number type. Now, I will create a new variable for the minimum salary standard of the company. We say that all of our employees must get at least this salary. This is our standard. So let's create that. We mean employee salary. It's a number and the value is 5,000. Now we will add our subprograms to do our job. I will start with creating a function that returns all the employees. So let's write it. Function get employees and returns emp table type. As you can see, I used emp table type as the return type. Since this type is in our package, I can send an associative array with that type to the other subprograms easily. Now, the second function will be about eliminating the employees whose salary is greater than the minimum salary standard. It will delete these employees from our associative array because their salary will not be increased. They are already high because this increase is not a general salary increase. This is an increment about the low salaries. So let's write it. Function get employees to be incremented. Return emp table type. As you can see, it returns an associative array back. The employees whose salaries are lower than the standard. So with this function, the high ones will not be increased. Now I will create our procedure that increases the salaries with using the other subprograms. I write procedure increase low salaries. Since this is our base subprogram, there is no need to return anything because this will do the main job. It could return, of course, but no need to return anything for now. Now, I will create my last function. After increasing the salaries, it will check if still there are any salaries lower than the standard. If so, they will be directly rounded to the standard whether if these salaries are very low or not. So let's write it. Function arrange for minimum salaries. We emp in employees percent row type and return employees percent row type. Now, since this function will be called from the increase low salaries procedure, it will return a record with the employees table type. Actually, it will get a record of the employee, increase the salary based on the increase rate. If it is still lower than the standard, it will update it with the standard. Then we'll return it back to the caller procedure. Alright, now let's compile it. Great, our package is compiled successfully. Now it's time to write the business within the package body. So let's copy the declarations of the subprograms and open up the body and paste it to the end of the package right before the begin keyword. Actually, you can paste it into anywhere. We know that the place of these subprograms is not important since they are declared in the package spec, but we cannot write them within the begin end block here. Begin end block is the last thing in a package body. By the way, as you remember, begin end block is optional. Alright, actually, as you can see in this body, the bodies are generally too big in a real work. Even if you try to divide the job within multiple packages, the bodies will grow in time and there will be a huge code at the end. And there will be so many similar named subprograms in a real work because maybe a lot of people will work on the same package. So when you want to use a package, it will be hard to understand what that code means or what job it makes. Actually, it will be hard to read all the code and try to guess. You won't do that. So my suggestions to you is try to add a comment about what you do in your packages. Actually, it will be better to comment the subprograms if they are public. For now, I will write here so that you will understand better. I will take them to the spec at the end. Great, so let's start with our first function, get employees. But first, let's write its comment. This function returns all the employees of the employees table in an associative array. The only thing that this function do is returning an associative array of all the employees in employees copy table. By the way, if you can divide your job into small pieces, it will be easier to maintain. Maybe you know, one of the principles of programming is single responsibility. Do not try to do everything in one subprogram. If you do like that, in time, you will have so many similar subprograms doing similar things, writing the similar code in them. So try to divide your code within a single job. So in here, the only job of this function will be returning the employees. With this way, you can use this function in anywhere, even within different packages. This is how we do in a real work. Great, let's write it then. Function, and we write is in here. Here I will create an associative array with the type that we declared in the spec. vemps emp table type. And our begin keyword. I will simply write a for loop with an SQL query in it and fill that associative array with the index of the employee IDs. For cur emps in, and our select statement, select all the columns from employees, copy, and loop, and our end loop. vemps and the index of cur emps dot employee ID is equal to cur emps. Now I will simply return the associative array. Return vemps. Great. Now it's time to fill our next function. Let's start with its comment then. This function returns the employees whose salaries are under the minimum salary of the company standard. Actually, the main goal of this function is it will get all the employees in an associative array by using the getEmployees function. Then it will remove the employees whose salary is greater than the standard, and then it will return that array to the caller. So let's continue. Let's add our is keyword, and first we will create our associative array to store the employees. vemps emp table type. Since this is an associative array, its index may not be sequential. And we learned in our collections lessons that first dot dot next statements will not work if it is like that. In order to do that, we create a new variable and iterate with using the while loop and that variable. If you don't remember, I recommend you to check the associative arrays lecture again. Alright, let's create it then. I employees dot employee ID person type, and our begin keyword and end keywords. Now, at first, we get our employees from the getEmployees function and store it into our vemps variable. So we simply write vemps is equal to getEmployees. See that? The benefit of single responsibility. I got the employees array with writing only one line. So you can simply get it within a single line in all the places you need. No need to write them all. Great. Now we will assign the first index of our associative array to our variable. We write I is equal to vemps dot first. Now we will create a while loop. While I is not null loop. And our end loop. Here, we will eliminate the employees whose salary is already greater than the minimum salary standard. So if vamps the index of I dot salary is greater than v min employee salary, then and our end. If it is greater than the standard, delete this employee from the total employee list that we have. As you know, we do it with our associative array name dot delete with the index. So we write vamps dot delete and the index of I. Now we need to assign the next index value to our indexed variable. I is equal to vamps dot next and with the parameter of I. Now we will return our eliminated employee list. Return v underscore amps. Alright, now we will fill our procedure to increase the salaries with using the other procedures and functions. But let's write its comment first. This procedure increases the salaries of the employees who has a lower salary than the company standard. So let's continue. Let's write as. Now we need an associative array variable here too. So we write vamps amp table type. We need a record variable to store a single employee. We write vamp employees %row type. And the I variable again to use as our index variable. I employees dot employee ID %type. And our begin keyword and end keyword. Alright, since this is our main subprogram, I mean the users will call this subprogram, not the others, we need to do all the job here. So let's start with getting the employees to be incremented. I write vamps is equal to get employees to be incremented. As you can see, we simply said that get the employees to be incremented. And this function got the employees from another function. I called one and it called another one. You will see that this will ease your job while your package is getting much bigger. Great. Now let's initialize our index I and create our while loop. In that loop, we will arrange the salaries for each employee. I is equal to vamps dot first. And while I is not null loop and our end loop. Great. Here I will use our range for min salary function. I will send the employees one by one as a parameter, and this function will increase the salary and return the employee with increasing the salary. So I write vamp is equal to arrange for minimum salary. And for the parameter, I send vamps with the index of I. Now we have the employee with an increased salary. So we can simply update our employees copy table with using our record. As you remember, we can easily update the complete row with using our record. Let me show you. Update employees copy set row is equal to v underscore amp. And our var clause where employee ID is equal to I. You might remember this from our previous lectures. but be aware that this updates all the columns. So if you change any other column in your record, it will also be updated. Besides, if someone has changed any other columns after you got this row into your record, but before you make your update, the changes of other users will be overridden. So you must be careful while doing that. But it's so simple to use this. I use sometimes if I'm sure that no one else works with that table. Now, let's update our index variable I with the next index then. I is equal to vamps dot next with the parameter of I. Alright, now we can fill our last subprogram. This function will arrange the salary. What I mean by arranging is, since we will send it a record of an employee to be incremented, it will first make the increment without controlling, because we did the control in our getEmployees to be incremented function. So the salary of this employee will be incremented without any control. Then it will make its own check. I mean, if the salary is still under the standard minimum salary, it will assign the minimum salary to the user. So let's start filling it, but let's start with adding the comment first. This function returns the employee by arranging the salary based on the company standard. And let's start with writing the is keyword and our begin keyword and end keywords. First, we will increase the salary with the salary increase rate without any check. So we write vamp.salary is equal to vamp.salary plus vSalary increase rate. Now we will check. If the salary is still low, we will assign it to the minimum salary. If, let me copy vamp.salary and paste here, is smaller than vminimum employee salary, then, and our end if, and vamp.salary is equal to vmin employee salary. Now we will return the employee record. Return v_emp. Let's write a comment line to separate this function from the begin keyword to increase the readability. Let's write something like that. Great. Now it's time to compile our package body. As you can see, we had an error. It says vamp.salary cannot be used as assignment target. As you remember, we had this error in the previous lecture when we set our variable as constant. But this variable is not constant. So why did we have this error then? Now, I want you to listen carefully because this is really important. The in parameters are read-only parameters, so you cannot change them inside of the subprograms. Actually, this is different in many programming languages, but in PLSQL, you cannot change the value of in parameters. So if you want to change that parameter, you need to define it as out or in-out mod parameter. But you need to be aware that if you set this parameter as out or in-out mod, when you update the value of that parameter in your subprogram, the value of the variable in the caller block will also be updated. For example, in here, if we set it to in-out mod, the ith index row of vamp array will be updated. So the caller subprogram may have some unintentional results because of this function. So be careful when you set a parameter as in-out-mod or out-mod when you are defining them. But for now, let's make it in-out and see if we can update. As you know, to do that, we need to start changing from the package spec. So let's open up the spec first and make the change. And compile. Great. Now let's turn back to the body. And do the same thing in here too. And compile. Alright, now our package is ready to use. Now it's time to have a break. We will continue this lecture with the next video.